How do we find the Laplace transform for these two examples here? Well, in this video, we are going to look at Laplace transform in the form e to the power at multiplying ft. From the previous videos, we looked at Laplace transform in the form of only, let's say, f of t, a function of f of t in a single function. So what if we have we have e to the power et multiplying another function? So in this case, there's a need for us to learn another rules, which is also known as the shift theorem. So I'm going to write the formulas that we need to be able to do calculations under Laplace transform of functions of the form this way. Functions like this. So let's start writing the formulas. I have a video on the other ones so you can try and check them out. It's going to be helpful if you watch those before watching this, but anyway, let's continue. The shift theorem is actually the modification of the other principles that we learned so far. For instance, if we have a function of the form, let's say t to the power n, and we are to find the Laplace transformation for this function, we are going to get n factorial and over s to the power n plus 1. So looking at this function of the form this way, looking at the function of this form, if we have a function of e to the power at, we are to find the Laplace transformation for this function. We are going to get 1 out of s minus a. So we already talked about these principles in the previous video. So let's focus on this Laplace transform of the form e to the power at ft for now. So the formulas you need to know are, if we have, let me change this here. The Laplace transform of e to the power at t to the power n is going to give us n factorial all out of s minus a into bracket to the power n plus 1. The Laplace transform of e to the power at sine wt is going to give us w all out of s minus a squared plus w squared. The Laplace transform of the function e to the power at sine h wt is going to give us w over s minus a all squared minus w squared. The Laplace transform of the function e to the power t cos wt is going to give us s minus a all out of s minus a squared plus w squared. Always you can see that our w will come from cos and our a will come from the exponential function. The Laplace of e to the power at cos hwt is going to give us s minus a over s minus a all squared minus wt. So keep these formulas in mind. We are going to use them in solving problems in this video. Now that we know these formulas, let's try applying them. So we have to find the Laplace transform for 2t e to the power 2t. And we know for a coefficient, we just leave it like that. So 2 into bracket. What is the Laplace transform of our function in the form e to the power t? So this function is of the form this. So we are going to use this formula. So now it's going to give us n factorial over s minus a to the power n plus 1. So and our a now is going to come from the e to the power 2t. So looking at this, our a now is, our a equal 2 here, and our n equal 1. Our n is the exponent of t, so n here is 1. So now let's start solving. So we are going to get 2 n factorial, and our n is 1, which is 1 factorial, all out of s minus a. We have our s minus a. What is our a? A is 2, all into bracket, raised to the power n plus 1, and our n is 1, so 1 plus 1 gives us 2. So simplifying this, we are going to get 2 into bracket 1 all out of s minus 2 squared, so which is going to give us 2 all out of s minus 2 squared. So let's work more problems. Let's work on more problems. So let's solve the second one, which is 2 to the power 2 e to the power t. So in this case, our a equal 1. Our a equal to the coefficient of t here, which is 1, positive 1, and our n equal 2. So we are going to get the function. So e to the power at, or the function of t to the power n, is going to give us n factorial over s minus a all to the power n plus 1. So now that we know our a and our n, so let's start. Our a here is 2, so we are going to get 2 factorial all over s minus a, and our a is 1, so s minus 1 to the power n plus 1. So n is 2 plus 1, giving us 3. So our final answer is going to be 2 factorial is the same as 2, giving us s minus 1 to the power 3. Determine the Laplace transform for 2 to the power t4, t to the power 4, e to the power 3t. So this is a coefficient, 2 here is a coefficient, so we just leave it like that when you open your bracket. So now that we have our Laplace transform of the form t to the power n e to the power et, we're just going to use that formula here. You have to recall these formulas. So now let's go. Our a, let's identify our a. Our a here is 3, and our n is 4. So n factorial, which is 4 factorial, all out of s minus a, s minus 3, all to the power n plus 1. Now n is 4 plus 1, giving us 5. So 4 factorial is going to give us 4 by 3 by 2, 4 by 3, 12 by 2, giving us 24. So we're going to get 24 over s minus 3 to the power 5 multiplying 2. So further more, we're going to get 2 by 2, 24, giving us 2 by 2, 4 by 4, 8, giving us 48 over s minus 3 to the power 5. So that's it for this problem. Let's work more. Find the Laplace transform for 4e to the power 3t cos 5t. With this problem, we have our e to be 3. So our e equal 3, and our e comes from the power of e, and our w, here we're looking at our w, which is 5. We know that the Laplace transform of the form e to the power at cos cos wt is going to give us s over it's going to give us s minus a over s minus a squared plus w squared. This is s minus a. So now let's simplify this. We know the value of our a and our w. So let's just substitute the values into it. So our a is 3. So we are going to get s minus 3 all over s minus 3 all squared plus our w squared, which is 5 squared. So this is going to give us s minus 3 all out of s minus 3 squared plus 25. It is best when we simplify our denominator to the last. So now let's simplify everything. So s minus 3 all over, let's square s, so l squared, so 2 and 2 multiplied by x multiplied by negative 3 give us minus 6s, and now minus a squared to give us positive 9 plus 25. So 25 plus 9 will give us 34. So our final answer should be s minus 3 all out of s squared minus 6s plus 34. So this is our final answer for this problem. Find the Laplace transform for e to the power negative 2t sine 3t. We know that Laplace transform of the form at sine wt is going to give us w all over s minus a squared plus w squared. So now from this problem, the value of our a is negative 2. Our a equal negative 2. And we have our w to be 3. So now let's start substituting. W3, so this is going to give us 3 over s minus a, and our a is 2 minus 2 all squared plus our w squared, which is 3 squared. So this is going to give us 3 out of s plus 2 squared plus 9. So let's further simplify this problem. So s squared, we square s, then we square we square s, then we are done multiply 2 by s and by 2. Then the last part we square 2. So 2 by s, 2 s squared is going to give us s squared. So 2 by s plus, 2 by s by 2 is going to give us 4s. And lastly, 2 squares will give us 4 plus 9. This should be 3 out of this. So now we are going to get 3 over 9 plus 4 will give us 13. Right. So s squared plus 4s plus 1 3. So that's for this problem. Let's work on 2 more problems. Find the Laplace transform for 3 e to the power theta cos h 4 theta. So how do we solve this? The Laplace transform of e to the power at cos h wt It's going to give us s minus a out of s minus a squared minus w squared. So looking at this problem, it's also in the form of this. So we are going to use this formula. And now what do? We have to look for our a and our w. So our a is from the power of e, and the coefficient of theta here is 1. So our a equal 1, and then our w equal 4. So 3 is just a coefficient, so we just leave it at that. So 3 into bracket s minus a is 1. So s minus a, s minus 1 divided by s minus a, s minus 1 squared minus w squared, which is 4 squared, giving us, let's write 16 straightforward. So let's multiply 3 throughout. So we are going to get 3 multiplying s minus 1 all over s minus 1 squared minus 16. So let's further simplify this. We are going to get, let me write this. Let's simplify this. We squared s firstly, s squared, and we multiply everything 2 by s by minus 1, giving us minus 2s. Then we square negative 1, giving us positive 1. So positive 1 and then minus 16. We already have a minus 16 here. So our final answer is going to be 3 into bracket s minus 1 all over s squared minus 2s. 1 minus 1 minus 16 is going to give us 1 minus 16 is going to give us minus 15. Let's work on one more problem. Find the Laplace transform of 5 e to the power negative 3t sine h 2t. So you see this is e to the power at and sine h at form. So we have to look for a formula like that. Looking at this, we have the Laplace transform of e to the power at sine hwt to be equal to w over s minus a squared minus w squared. So we are going to use this formula, and comparing this formula now to our problem, we see that our e from this point is minus 3 and our w is 2. Our w from here is 2. So now let's start substituting. We're going to get w over s minus a all squared minus w squared. So this is going to give us 2, but don't forget we have 5 here. So 5 is multiplying the whole thing. So I have to bring 5 here. 2 out of. So now we have w, which is 2 over s minus a, and a is 3, and it's a minus. So minus 3 is going to give us positive 3, then squared minus w squared, which is 2 squared, giving us 4, all multiplied by 5. So 5 by 2 is going to give us 10. So 10 all over s plus 3 squared minus 4. So let's simplify our denominator. So s squared, 10, s squared, 2 by s by 3, 6s, then finally 3 squared, giving us 9 minus 4. So our final answer is going to be 10 over s squared plus 6s plus 5. 9 minus 4 giving us 5. So this is our final answer for this problem. Let me add this. So lastly, find the Laplace transform for 2 to the power 2e to the power 3t into bracket 4 cos 2t minus 5 sine 2t. So how do we solve this? It will be better if we expand the bracket. So 2e to the power 3t by 4 cos 2t. So 2 by 4 is going to give us 8. We are going to get 8e to the power 3t, then our cos 2t. Then now 2e to the power 3t by minus 5 sine 2t. So 2 by minus 5 is going to give us negative 10 e to the power 3t and then sine 2t. So now we can go ahead and simplify this. But then we have to recall our formulas to see that we have e to the power at in terms of cos and also in terms of sine. So from here, we could see that our a equal 3 and our w here equal 2. Our a here equal 3, our w here equal 2. It's virtually the same. So now we have to recall the formula for e to the power at cos wt and that. So you can see for e to the power at cos wt, we're going to get s minus a. So let's bring our 8 here. 8 here is a coefficient here. E to the power, sorry, going to give us s minus a. And our a is 3, all divided by s minus a, which is 3 squared plus w squared, which is 2 squared, giving us 4. And here, we are minus 10 multiplying for sine. We are going to get w over s minus a all squared, and then plus w squared. So w here is 2 all out of s minus a, and our a is 3 all squared plus w squared, which is 2 squared, giving us 4. So let's further break it down. 8 to multiply 2, we are going to get 8s minus 3 all out of, let's expand this bracket. Let's expand this expression. S minus 3 to the power 2. So s, we squared x, we square s, giving us s squared. So 2 by s by minus 3, giving us minus 6s. And finally, minus 3 squared, giving us 9. So now minus 10. Minus 10 by 2 can give us 20, right? So 20 all over s squared. So we are virtually going to get the same thing here. So s squared minus 6s plus 9 plus 4. So let's further break this down. Here plus 4. So we are going to get 8 into bracket s minus 3 s squared minus 6s. 9 plus 4 is going to give us 9 plus 4 giving us 13. So s squared minus 6x, minus 6s plus 13 minus 20 over s squared minus 6s plus 13. So we are done for this. You can go ahead and simplify it too. In our next video, we'll be looking at inverse of Laplace transforms. Thank you for watching.